Welcome students. We are going to see fractions. Do you know when fractions come into existence? When one whole thing is divided into equal portions, fractions come into existence. I have shown you a chocolate in which it is divided into 1, 2, 3, 4, 5 and 6 portions. So 1 upon 6 will be the fraction. Example, an apple. When you cut the apple from the middle, the apple becomes half. So 1 upon 2 will be the fraction of that half apple. When I cut the watermelon into half, the fraction will be 1 by 2. When two parts are again divided into two more parts, the fraction I will get is 2 by 4. When I cut the 3 portion of watermelon into 6 parts, I will get 3 upon 6. All these fractions, that is half, 2 upon 4, 3 upon 6, are same. All these fractions are called equivalent fractions as they give you the equal amount. To explain it in a better way, let me show you a figure. There you can see two circles. One circle I have divided into 3 portions and another circle I have divided into 6 portions. In the figure there I have shaded 2 portions from the 3 portion. So the fraction expressing it will be 2 by 3. Now this next figure where I have 6 portion, I am shading 4 portion. So the fraction will be 4 by 6. Observe the figure properly. Can you see that 2 by 3 is equal to 4 by 6? The only difference is in the next figure, that is in 4 by 6, I have divided the circle in more portions, that is 6 portions I have divided it. But when I take 4 by 6 and 2 by 3, the portion that is shaded comes out to be equal. Now we will see how you can obtain an equivalent fraction. When the numerator and the denominator of a fraction are multiplied by the same non-zero number, we get a fraction that is equivalent to the given fraction. Let us take an example. 1 by 2 is equal to 2 by 4. Now let us see how we are getting it. If I multiply 1 by 2 by 2 upon 2, that is 1. So I will get 2 upon 4. Therefore 1 by 2 is equal to 2 by 4. Understood? Let us check 1 by 2 how it is coming equal to 3 by 6. If I multiply 1 by 2 by 3 on both the numerator and the denominator, I will get 3 by 6. That is why 1 by 2 is equal to 3 by 6. So, if the numerator and denominator have common divisor, then the fraction we get in dividing them by the divisor is equal to the given fraction. Suppose you are given 15 upon 40. You have to find the equivalent fraction for it. Can you find what is common in both of them? See, in the numerator, can I write 5 into 3? And denominator, again I can write 5 into 8. So 15 upon 40 will be equal to 3 by 8. So 3 by 8 is the equivalent fraction of 15 by 40. Let us see few more examples to make the concept clear. Here I have given you 2 upon 3, 5 by 7, 5 by 11, 7 by 9, 14 by 18, 15 by 33, 18 upon 27 and 10 by 14. We have to find or make pairs of equivalent fractions. Let us start from the highest, that is 14 by 18. You can see I can write 14 by 18 as 2 into 7 and upon 2 into 9. So the equivalent fraction of 14 upon 18 will be 7 by 9. Yes? Let's now take 15 upon 33. 15 upon 33 I can write 5 into 3, that is for the numerator, and for the denominator I can write 11 into 3. So 5 upon 11 and 15 upon 33 are pairs of equivalent fractions. Now let us go to 18 upon 27. 18 upon 27 can be written as 2 into 9 in the numerator and in the denominator 3 into 9. So 2 upon 3 and 18 upon 27 are equivalent fractions. Similarly, I can see that 10 upon 14 and 5 upon 7 are pairs of equivalent fractions. There are many different types of fractions. One of them are like and unlike fractions. If the fractions like 1 by 5, 4 by 5, 6 by 5, here you can see that the denominators of all these fractions are equal. That is, 5 is there in the denominator. Such type of fractions are called like fractions. Fractions like 9 by 11, 3 by 7, 1 by 5. Here you can see that in the denominators there are different figures, that is 11, 7, 5. All of them are different. So such type of fractions are called unlike fractions. Here I have given you 3 upon 4 and 5 by 8. You have to convert both these fractions into like fractions. First, check whether they are like or unlike. In the denominators, I am having 4 and 8. They are different, so they are unlike fractions. You know, all the unlike fractions, you can convert them into like fractions. Let us see how we can do that. Now, to convert them into like fractions, what I'm going to do is I will multiply 3 upon 4 by 8 in the numerator and 8 in the denominator. 8 upon 8 will be equal to 1. So 8 is a 24 upon 32. 5 upon 8, I will multiply both the numerator and the denominator by 4. So I am getting 20 upon 32. Therefore, 24 upon 32 and 20 upon 32 are now like fractions because you can see their denominators are same. We will take one more example. 1 upon 6 and 4 upon 9. Here 1 upon 6 and 4 upon 9, 6 and 9 are there in the denominators. To make them like fractions, what I am going to do is 1 upon 6 I will multiply by 9 upon 9 and 4 upon 9 I will multiply by 6 upon 6. Now we will see comparing of the fractions. First, let us see comparing like fractions. In the like fraction, the denominators are same. The only difference is in the numerator. Now, we have to find out. Suppose I have given you two fractions, 3 by 6 and 4 by 6. You have to find out which fraction is bigger. So, in the like fraction, the fraction with the greater numerator is the greater fraction. For better understanding, I have taken a strip that I have divided into 6 equal portions. Here, I have shaded 3 portions, so the fraction I am getting is 3 upon 6. The next strip is again divided into 6 equal portions, but here I have shaded 4 portions. So the fraction I am getting is 4 upon 6. Now I am supposed to compare both the fractions. You know that in like fractions the denominators are same. So now we will compare the numerators. In the numerators, 3 upon 4, from the figure also you can make out that 4 upon 6 is bigger than 3 upon 6. So understood, if you are supposed to compare like fractions, then you will see the numerator. Whosever numerator is big, that will be the bigger fraction or the greater fraction. For comparing two fractions with equal numerators, the fraction with the greater denominator is the smaller fraction. I have a very nice example to explain this. Suppose I am having my birthday and I have invited my 4 friends for the birthday party. So I will divide the cake into 4 equal portions. So the fraction that I will get will be 1 by 4. Now I went to my friend's house and they had ordered a cake for me. And here I am having 8 friends. So I will divide the same cake into 8 equal portions. So the fraction I am getting is 1 by 8. Now tell me, if I divide the cake into 4 portions and if I divide the same cake into 8 portions, which portion you will get a bigger portion to eat? Obviously, when it is divided into 4 portions. When I divide into 1 by 8, I am getting a smaller portion to it. The fraction 1 by 4 will be bigger than 1 by 8. The fraction when the numerators are equal, the denominators which is greater is always smaller than the denominator which is smaller. Suppose you are given fraction 4 upon 5 and 1 upon 11. Now let us see how we can compare unlike fractions. To compare this to unlike fractions, first thing I will do is convert them into like fractions. That is 4 upon 5. To make it like, I have to multiply numerator and denominator by 11. So 4 into 11 upon 5 into 11. What I will get? 44 upon 55. So 1 upon 11, to make it into a like fraction, I have to multiply it by 5 upon 5. So 1 into 5 upon 11 into 5. So I will get 5 upon 55. Can you see now both the numerators are same. So it has become a like fraction. So here we will apply the rule of comparing like fraction with the same denominator. The fraction with the greater numerator is the greater fraction. So 44 upon 55 is bigger than 5 upon 55. So in this video you saw equivalent fractions, like fraction, unlike fraction, how to convert unlike fraction into like fractions, comparing like fractions, and comparing unlike fractions. Now, till we meet again, keep learning new things every day.